In the last few lectures, we were looking at the topic of boiling heat transfer. What we're now going to do, we're going to move into the opposite of boiling, which is condensation. That's where you're going from a vapor back to a liquid. So when we look at condensation heat transfer, what is happening is we have a surface that is at a temperature lower than the saturation temperature of a vapor, and consequently what happens then on that surface is the vapor goes through a phase change and it goes from the vapor state back into the liquid state. Now, there are a couple of different types of condensation that can occur. So the two different types of condensation that can occur, on the left what we see is what we refer to as being film condensation. And what happens in film condensation is we get a film of liquid that wets the entire surface, whereby we have condensation occurring. And then that is countered by droplet condensation, which we have on the right-hand side. And with droplet condensation, you get little droplets forming on the surface. Sometimes they will connect with one another, and then due to gravity or whatever the angle of it might be, but usually be gravity, would pull them down, and then they would descend due to their own weight. So those are the two different types, and you can imagine the heat transfer characteristics are very different depending upon whether or not we have film condensation or droplet condensation. And for the most part, what we're going to be doing in the next few lectures, we're going to be looking at film condensation versus droplet condensation, just because the heat transfer for film condensation is actually worse, and consequently it's a more conservative estimate to be doing your calculations using film condensation. Okay, so the reason why film condensation is less efficient is because as the film thickness grows, what happens is that the condensate, or the liquid that is forming on the surface, actually provides a thermal resistance, or almost like an insulating blanket to the surface, and it then minimizes the amount of condensation that's occurring. And so in order to counter this, typically condensing units where you have condensation occurring on the outside, try to minimize the length of the vertical surface. And so if you look at a condensing unit whereby you have tubes that might be arranged in something like this, and we'll be looking at this type of scenario later on, and this would be where you have what they refer to as being shell side condensation. So the condensation is occurring on the outside of the tubes, but by having these tube bundles like this, you'll get droplets forming, and then the liquid will drip down and it will go on to the next surface. But you're minimizing the overall length that you have in the vertical extent by having a lot of tube bundles like that. And then each of these additional ones, we would have liquid coming and falling. And then eventually at the bottom, you would collect all of the condensed liquid that you could then use in whatever other process that you're trying to achieve with the system. So you'd have condensation flowing down. But we minimize the vertical extent in order to minimize the film thickness and the insulating effects that it might have. And so here we would have droplets forming on the tube bundles. And this is what they sometimes refer to as being shell side condensation. And the opposite of that would be tube side condensation, where the vapor is flowing through the tubes and you have condensation occurring on the inside. But that would be a different type of application. We probably will talk about that a little bit more in a later lecture. But anyways, so that is a bit of a review of the physical processes that are occurring. What we're going to do in the next segment, we're going to take a look at some engineering applications, and then we're going to look at some of the theoretical developments that were put together by a fellow named Nusselt. And we've heard of Nusselt many, many times. We use the Nusselt number for convective heat transfer. He did dimensional analysis and came up with an amazing model that was really quite accurate for determining the amount of heat transfer when we have condensation occurring. So that's where we're going.